Alrighty. Thank you for coming to wasmCloud Wednesday. It's our first Wednesday of November, and we've got a pretty cool demo of the next version of wasmCloud that Lucas is going to show. I figured we would have a discussion around that afterwards, so I wanted to allot time for that. And then Victor's going to give us an update on his work on WASI P3. And then I'm going to make a couple different shouts for CFPs, upcoming conferences, that kind of thing. So let's get started with a very cool and fun demo. Lucas, you want to take us away? And
Awesome. Let me see. Let me steal the share. Here, and can you see my browser there?
yep.
Just all right. That's the right window. Okay, so what are we talking about today? We've been cooking on wasmCloud v2 for quite a while, and we are approaching a point where we have all the pieces needed to kind of show everything working in one go. What I'm going to show today is the setup and a bit of how it works, how everything is looking like from the outside. And the code that I'm going to be jumping on the terminal in a bit is here in wasmCloud Runtime Operator. So let's do that. So here I have Runtime Operator repository. And first thing I'm going to do is get myself a Kubernetes cluster. It's going to take a couple seconds there. Now that we have Kubernetes cluster, we're going to install the runtime operator and the new wasmCloud host that communicates here with the operator using nats. And for that, we're going to do a make helm install. And what is happening here, I'm going to run the exact command that is coming from the helm charts. We're going and setting up the wasmCloud system namespace with a few deployments, and those deployments will contain here nats, which is a message bus that we are using, the runtime operator, which is responsible for getting the CRDs and scheduling the work, each individual workload on the host groups. And we have three host groups, one called default, which doesn't expose HTTP, one called private ingress, which is an HTTP capable host, but only answers for internal requests, and a public ingress, which is a HTTP capable host that is intended to respond to external requests, public requests. We're seeing them all here in error status because nats has to be up for everything to be up. So if I run this again, it should be all running. Nice. Right now we have everything installed, system is running. Very first thing that we're gonna do here is see how many hosts do we have. So for that we do Kubernetes get host. The same way that Kubernetes itself has the command get node, when we're doing get host, what we're actually getting is hosts runtime wasmCloud dev. And these are the individual pods that are hosting the wasmCloud host, thus letting us see which hosts are available. Then we can place workloads on those hosts in a multi-tenant way. We have three host groups here. If I go on wasmCloud system and get the pods, you see that we have here three pods. We can increase the number of pods in this deployment, which means that host group will have more capacity. So I think this is to say that it works exactly the same way as a node selector would in Kubernetes. So we have the system up. Let's get one of those hosts just to see a bit of their information. And in here we have information about the host itself, the architecture, the CPU usage version. We also have the labels that this host should respond when we're doing host selectors. So this is to say, I want to deploy a component, but I want to deploy this component only on this group of hosts. So with all the hosts up, next thing that we're going to do is place some workloads there. And we have a sample here, a sample deployment, which is pretty basic, but can give an idea on what we're talking about. This is going to be a workload deployment under Runtime wasmCloud. And we just want one replica of this workload being deployed. We want to deploy it to the public ingress host group. And in here, we declare which interfaces from the host we want to make available for this workload. So by default, none of the host capabilities will be exposed to a component. It has to be, you have to tell the sandbox, I'm allowing this component to have access to this interface. So we have an HTTP component. That means we need access to WASI HTTP incoming handler. And we also have a field here for configuration where we can pass any configuration this interface on the host side might need to tie this workload to an external resource. In this example here, we want the HTTP host, localhost, to be mapped to the component that we have here. The important part is we have on this side here the WebAssembly component. And on host interfaces, these are on the host itself, meaning it's Rust code. So when we're passing all this interface definition and configuration, what we're saying is start this host plugin with this configuration, and that's going to be individual to this workload. So it's isolated from other workloads. Also notice how we are not specifying here a wRPC provider, an external provider, links, or any of that. This is the entire setup. So after taking a look at that, let's apply it. Whoop. Right, so now we're creating the workload deployment. It's already up. What this is creating is a workload deployment, which we talked a few community calls back. We have the concept of a workload deployment, a workload replica set, and a workload itself. And those three, they are workloads. They are pretty much mapping to Kubernetes deployments, replica sets, and pods. And here we see that the deployment landed on this host. And we're going to do a get host here just to show we asked it to be placed on the host group public ingress, therefore that's where it landed. Now with this, we should be able to do curl localhost, and we are reaching a component here. So that's pretty much how I set it up locally when I'm testing and making sure and getting it ready for deployment. The important thing here is this has been installed using Helm. This Helm chart is available here in the Runtime Operator repository. We have not published this here yet to GHCR, but we will. Now the question is, well, which host is this using? Like what is happening here? What is running? So what we're running here is essentially wash. And we're running wash off this pull request in the wash repo, where we're bringing a command to wash called wash host. So the same way that in wash you have wash dev, wash build, wash so on. Now we have wash host, which makes that binary act as a cluster host. And we pushed it to a temporary image here just so we can have this demo, have this conversation. But I can execute it here just to show what I'm talking about. So this is the wash Docker image. And you can see that we have the usual wash commands, build, config, and so on. But we also have this new one here, host. And this is the one responsible for, and we can do host help. Yes. This is the one that literally brings up the wasmCloud host, now wash host. And the settings to kick off a new host now are pretty minimal because all the intelligence for scheduling has now been moved over to the operator. So there is no expectations that the host would be acting on its own without a scheduler ever. The the other thing going on here is we we made it so you can bring in your own scheduler. So if it gets to the point that you don't want to be tied to Kubernetes, what you would do is you would implement your own scheduler, and we are providing here facilities to do that in, I'm pretty sure it's going to be here. Oh, not here. I sent it some people a few days ago. Sorry about that. Workload clients. So the all communication from the operator over to the host for scheduling is encoded into a single Go structure here. So if you were to implement this for any other scheduler, this would be the code that you want to steal. What this code is doing is getting the protobuf messages that we have. For example, let's get the host heartbeats. We have the message definition defined in proto, and we get this protobuf and we encode the messages in JSON format and send them over NATs. So this way we have ready to go clients for Go, for Rust, for Python, and other languages. So if you want to write a scheduler for wasmCloud using any language, what you want to do is grab this protobufs here from the runtime operator and build your own. Now, there is also the angle that I don't want to build a different scheduler. I want to build a different host altogether. I don't want to use NATs. I want to use something different. We are also looking from that angle, and inside this pull request here, we have, let's go there. Where's host? Let me get this file. What we have now is a really easy to use builder, Rust builder pattern, where you pass the very minimal information to the runtime and you can bring in your own plugins. The runtime is coming from a few built-in plugins that we are enabling by default. Still not sure if we're going to have them all always enabled or if this is going to be on a switch, but you can add your own with interfaces as plugins here. And in this example here, the one that we're about to ship for Wash Host, we have WASI config, logging, blob store, and also wasmCloud messaging. wasmCloud messaging being the one that is not part of the WASI family, but we're also including it because it's wasmCloud. And all these plugins here, they have a sibling for the development story. So you see Wash Blob Store in local development, we're going to use a temporary directory. When we go to the host implementation, it's backed by NATs. So everything that is ephemeral in local development has a NATs backed counterpart for the production for the production plugins. And we are wrapping up this pull request here with a few other things to clean up. Let's go back there. The conversation. Come on. There are a few other things here to wrap up, and many of these they already exist in some capacity, but we are making sure that we're cleaning up to a point that we can call this a release candidate. And once that's done, we pretty much have wasmCloud v2 ready for the presses. All right, so talked a lot. We'll stop here and see if there's any questions, if we want to see anything in the environment here. I see a hand up. Victor, go ahead.
Oh, yeah, I just wanted to point at the question in chat.
Oh. Will we have auto-scaling for hosts? Great question. So auto-scaling now is it's kind of orthogonal because when we think about auto-scaling will happen at this layer. So to get auto-scaling going here might mean two things. Auto-scale my hosts, as in my host is running at 80% CPU, therefore I need more hosts. Or it might be I have more components, therefore I need more hosts. And for the first case, which is auto-scaling the number of hosts that you have, you would create a horizontal pod autoscaler and point that to one of these deployment targets here. The Helm chart doesn't have automatic horizontal pod autoscaler set up for you. Something that we can add, not opposed to that at all. It's mainly that we have not seen the need to do this at this point because it is possible to layer it on top of the configuration. Auto-scaling for the components themselves, this is something that we have not looked into at this point. And on the host name, wondering how namespace is WASI. So I'll pick samples. And I'm assuming that is kind of this section here. So the namespace here is WASI because these are the WASI interface. So not that one, WASI HTTP. So it's essentially the WIT interfaces that we want to get from the host. If we were using wasmCloud messaging, for example, then this here would be wasmCloud messaging, and I think it's producer, something like that. So the namespace in this part here has to do with which WIT namespace you want to import from. Now, in terms of where namespace also shows up is here, but this is part of Kubernetes itself. So you can create this workload here in pretty much any namespace that you want.
Yeah, so that was a confusing part to make sure because coming from Kubernetes side, namespace is your logical breakup and so forth. And now within the host interface, there's a namespace there. So I was wondering about that.
That's great feedback also. The host interfaces here is almost like we should be calling this WIT interfaces from the host. But we have host interfaces in there. This is also one of the things that is fairly easy for us to adapt and change. What else we have here? Doc for the CRD updates. Yes, this here is the most like basic setup if you want to do like a hello world. If you want to, what we're looking into now is have a few samples for Blobby, for other interfaces, wasmCloud messaging as well, and show a bit of the different patterns on composing applications using WebAssembly. You notice that when we talk about host groups, we have 3 different host groups in here. And why is that? There's a reason, and the reason has to do with separation of concerns. One is responsible for ingress. That means if you're trying to write a CDN-ish use case, that's the kind of ingress you want to use. There's the private ingress, which is if you not working on a CDN, but you working on a bunch of HTTP servers that are only internal, that's the type of host group you want. And the default host group for the case that you want to create a bunch of WebAssembly components for background jobs. They don't need to receive HTTP, but they need to subscribe to message buses, send HTTP requests out. They are invoked by other parts of the system. And with these three host groups here in the development setup, you can compose all those different deployment patterns. Cool. Any other questions, comments? Otherwise, I give back to Bailey there.
Can you control the names host group private ingress and host group public ingress, or spin up other like how much control do you have over this kind of stuff?
Awesome. Thank you.
Random curiosity there.
Yeah, notice how we started doing the make kind setup and then make Helm install. The make Helm install is installing this values local. And you see that here let me open this somewhere that we have a bit more colors. So the setup that I did here is the exact same Helm chart that can be used to deploy on a remote Kubernetes cluster, deployed locally using a values YAML that maps my local setup. So for the runtime, we don't have the wasmCloud image out yet, so I pointed the runtime image to the temporary one. In real deployments, you would not have to do this. And then we have the list of host groups that you want to create. And here I specify that I want a public ingress host group with one replica, this type of service, exposing HTTP as node port, and limiting the amount of CPU and memory for that sandbox. And I declared all the host groups that I want. So that's why we have 3 in here. If you don't specify any, the default is to have a single host group called default with HTTP enabled, which is like the get you out of the door running environment. But you should customize the host group list.
And Lucas, do you mind pulling up what the host group, like maybe do a describe on a host, just to show that the runtime operator is looking for basically annotation to know that this is a host. Because I want to emphasize that this is for end users. It's kind of like the linker de-inject thing, right? Like you tell us, we can schedule to you, and you decide how this looks.
Yeah, so if we were to go ahead, sorry.
And then I'm not entirely sure how to phrase this question. What piece of this is deploying the proxies that actually, I should phrase that differently. In what way is ingress from outside the cluster being affected here? Like, I assume that you have a proxy running someplace and a load balancer service and all that. What controls that sort of thing?
Awesome. So what we have here is every host group that we create in the Helm chart, we create an associated service for that host group. And the service can be cluster IP, node port, load balancer, headless. And once you create in a production environment, this one here would be a load balancer, for example.
Right.
But for local, we're doing node port and mapping port 80 to this crazy port number here, which if we look at in our kind, where am I here?
Actually, that port number is sadly familiar to many of us.
So that's the thing. Yeah, so then in kind, what we do is we tell kind any traffic for this port here, map that to the host, to the development host on port 80, and that's why the curl works. So this is like I want to see wasmCloud running on my local computer as easy as possible. And if we were to install this on a remote cluster, values YAML here would be significantly different.
Yep. Cool. Well, I have to run to a different meeting, but this looks cool.
Awesome. Thank you.
I'm looking forward to playing with it some more.
All right. And back to you, Betty.
Thank you.
Yeah. Thank you, Flynn. See ya.
Yeah.
And for folks that don't know, WasmCon is next, WasmCon NA in Atlanta is on Monday. And Flynn and I are giving a talk where we're going to run exactly what Lucas just showed, but meshed with Linkerd. So I'll have a setup, intending to have maybe a load balancer set up and show more of the Ingress side. But it all just kind of works as kind of the TLDR because we're building into all the things that are already there in Kubernetes. So it's a pretty nice native integration. I dropped a link to us already landing docs. I think the main call out here that Eric's been working on is we've now changed the label from next to v2.0.0 RC1. So this is where we're ready for release candidate feedback. We've got what Lucas just showed you was we've got the wash runtime crate buttoned up. That's embedded in the wash dev command. It's embedded in the wash host. It's all in that same wash binary now, so it's one binary. And then he showed it end to end being operated by the runtime operator that is now out in the WasmCloud repo. We're about to cut that tag, so technically that tag doesn't exist yet, but maybe later today, you will see it, and then instead of where we were using our test GHCR reference, you'll be able to find basically all of these things in GHCR. But if you want to, we were also in parallel working on getting the documentation together, and as Lucas called out, working on getting more examples and demos together so folks can get a hold of this and try it out. Oh yeah, Masood?
Hi, Bailey.
Hey.
Thanks for the presentation. I have a question that is more related to version 2,
Mhm.
and that partially goes back to the exchange that we had about building HTTP into HTTP provider as a transport, I mean, right? Or separating transport into a separate plugin, let's say. So you can replace it between, web version, NATS version, and so on and so forth. So basically, you would have your wRPC transport as a separate plugin. So that's one part of
Right.
it. The other part is about service type host plugins, the ones that basically are succeeding the providers today, right? Is it reasonable to assume that such services should have two implementation, one for local communications and one for wRPC or remote communications? Is that reasonable to say that those should exist?
Let's start with the first set of your question, then we'll go to the second part.
Okay.
So the first one is, I think essentially how are these components even just like doing their networking? What's their transport? Is the first part of it. I pulled up, and I forgot to call this out. We published a blog today. And this is a blog that Brooks and Eric have been working on for a while. And it details the architecture for all of these different kinds of things. So hopefully this is very helpful. And then we've linked to some of our initial features and design discussion around, how and why we're making all of these changes. And they are basically all have an implementation now. So back to your question. I've got a component that's deployed here, and you saw in the workload deployment spec that Lucas showed it is depending on WASI HTTP. Now, in theory, what provides that WASI HTTP interface, it's virtualizable. It's whatever this plugin here decides to do to implement that. What we provide by default is just regular old HTTP. No special tricks there, and it means that there's no extra networking hop. What we had before with capability providers, which I would actually describe, these are more what is replacing a capability provider, your host plugins, versus not necessarily a service. And I'll get to that part in a second, but essentially, if you wanted this to be over wRPC, that is an option that you could implement. But I think perhaps what you could also do is have an interface that is literally, wRPC namespace, whatever you're trying to do. If you want to try to do something specifically over an RPC style networking transport, be transparent about it in your component, so that you're not slipping into some of the laws of fallibility of thinking that you're doing a not networking call and then all of a sudden doing a networking call. So be very explicit about the type of networking that you're doing, and that way also being able to expose those errors. And in that scenario, then you would have a plugin that is a wRPC specific plugin that provides that interface. Now, moving to the second part of the first part of the question, about like how does the service work? We have included an example of a cron trigger. And I think when you think of a service, it's probably easiest today to just think about things that you would use as types of triggers. Cron's a good one. There's probably some others. Before we move on to the second part, Lucas, did I get everything there? Anything you would add?
Yeah, I think the service here is what we need to kind of explain a bit better going next. The challenge with WebAssembly is everything is invocation based, so there's no concept of like global values and things that survive throughout multiple requests. What we're doing here with service, this is giving this workload a place where it can run long-running code. So you can create an infinite loop inside the service, and it's going to act like a regular Unix process for all intents and purposes. You can open sockets inside the service, both inbound and outbound, and you can communicate with other components that are inside the same workload. So what this gives you is the ability to create a very simple service that is doing while true call my sibling component. And there you go, you have like a cron trigger of some sorts. And this plays a lot with the identity and network addressing of each individual workload, which is something that we, as part of this pull request in the Wash repo, we are also validating. But you can think that we will have the ability now to literally pinpoint every single workload inside the host by giving it a unique host name, a unique IP address, a unique network identity in general.
So Lucas, for this service that you're creating, what's your idea in terms of doing health check?
Awesome question. So the service here, when a service is optional in a workload, when a service is present, it becomes kind of the supervisor for all the components in that workload. That means if the service is down, we consider the whole workload to be down. The service comes with a few settings for restarts. For example, restart max of 3 times or never restart it. But the service is essentially the health check of that individual workload. And in terms of what is being health checked, on the runtime is checking if the WebAssembly sandbox is still active. So inside, you can be doing HTTP checks. You can be checking for file system things. It's really not important. It's more like if we think of it as a Unix process, if the Unix process is running, everything is good. But if it crashes, then we replace it. We put it in a different host.
Is this already documented somewhere, or because I mean, what you said, it makes sense.
Yeah, I think it's coming as part of this documentation drop here.
We've got some, but more feedback, super duper welcome. So do we cover service in here?
Yeah, I don't think we have mentioned service at all here.
No, we don't yet.
There you go.
There's definitely more to add. I think, right now we just have that one cron trigger as an example. I think that'll be a good thing, a good initial target to expand out.
Yeah, and just to kind of quickly touch up on this, is this complicated? This seems like this is some weird stuff going on here. What are we trying to enable? Challenge with components is because it's invocation based, is how do you do connection pooling? How do you do long-lived resources? So by having this concept of service on a per workload basis, we now have a place that we can run PG Bouncer, for example, where each workload has its own individual PG Bouncer, and they have 1,000 component concurrency. That means you're funneling 1,000 TCP connections into a single PG Bouncer connection out to your database. So we're gonna use it as an aggregator point for the workload.
Now, Masood, you had a second. It felt like maybe a second set of questions. Do you mind reminding me well, first, did we answer your question initially, and then get us started on the next part there?
I do need to write one of these plugins myself. And once I write it, I think I'm going to kind of get the hang of it all, right? So I have all the pieces. Still, I haven't been able cognitively to connect all dots. And that for me requires to go through one exercise of writing one.
I agree, and I think here if this helps, if you have ever implemented a WASI a with interface on top of WASM time using the component macro and so on, in here it's exactly the same thing. You have one extra trait that you have to implement, which is the host plugin that tells the host, I want to be a plugin, and these are all the interfaces that I want you to send my way. But once it's very minimal. So take a look at the WASI HTTP one that I shared there, or maybe start with the WASI config one, which is I think the tiniest. And because it's like if you've seen WASM time code, this is gonna be no news to you.
Yeah, just 122 lines there for that one. But you see, you get basically direct access to some of the WASM time interfaces.
No, I see. Okay. Yeah, I have worked with Wasm time. So, okay. So basically, the services are now given more authority in terms of managing some of the relationship with the runtime, Wasm time runtime, right?
And
Right.
it's important to highlight this is native code.
Yeah, and I think Masood he understands the current wasmCloud runtime, and that's exactly the call out. We don't have an abstraction in front of WASM time anymore. When we're
Right.
writing plugins, you can go straight to WASM time.
Right. Okay. I hear you.
And actually, Mindy's going to be dropping in WASI Web GPU PR pretty soon. And that'll be another example of how somebody can just slot in something that they were working on as part of a WASM time extension straight into this with our plugin interface. Okay. Masood, you had more questions, I think. But what your feedback there, what made me think of was like, it would be really wonderful in terms of one of our next documentation tasks to create a tutorial how to add my own host plugin and build my own wash host. That would be a really great V2 doc to get together.
And that would be awesome. The second was about these host plugins that will act as providers. Like again, because one of the goals, as I understood, was in version 2 was to kind of differentiate between in-process versus out-of-process communications. So my question was that when it comes to such plugins, do those two like still apply, saying that a provider components or provide services to components that are on the same host, or they are located on a different host. And so we have, let's say, local transport versus remote transport over wRPC or something like that. Like I'm saying that these type of providers, should they each have both implementations provided?
Yeah, at the moment, everything lives inside the host. All the calls are local. So the idea here, if we were to bring the wRPC into the mix, could happen in a few different ways. It could be a workload service that does the wRPC communication out using TCP, NATs, whatever that is. This is because now services have TCP IP capabilities. It could also be a host plugin, but if you make that as a host plugin, you also need to address for the permissions, who can call who inside the workload mesh of sorts. So that part we have not got into. How are we seeing communication from between one component to another using wasmCloud messaging? wasmCloud messaging is part of the host now, and you don't need any setup at all. You don't need to kind of tell me which NATs host or any of that. You add the interface and you say which topic you want to listen to. So this way you can send JSON messages back and forth across components, which gets you that RPC feeling of the wRPC.
Yeah, that actually reminds me, that was one of the things here for making this distributed networking more intentional. And that's what we're calling out here. And the solution is essentially making networking internal to components as part of the workload. And you can think of the workload itself as a form of tenancy. That is the tenant. This is its box. And what I'm so excited about this one, and is that when you think about it, when you look at a workload, what you really should think about is that this is basically an entire composed component itself. It's its own world in WIT terms. In the future, when we have features in the component model like runtime instantiation, we could do really cool things like having a service that acts as an HTTP router where each component serves on a specific route, and it would only need to instantiate the routes that are actually being called and used, and it wouldn't need to instantiate the other components. That's the type of flexibility we're able to do with this type of design. Frank?
From the point of view of multi-cluster, since we're talking about this is a Kubernetes construction here, I'm wondering, have you started thinking in terms of if I'm running this in multi-cluster, is that something that I can commonly handle, or I have to, I don't know, be aware of the different clusters and so forth?
Yeah, we're following what Kubernetes is doing. I think that's the gist. If you have a cluster that is multi-regional, then your setup is now multi-regional. But if you have a cluster that is like just 3 nodes in a bedroom closet, again, it's cool as well. We're not trying to solve here for the multi-cluster who talks to what. The management here is really within the Kubernetes boundary. You can add a layer on top of this all. So you can deploy, for example, a virtual API server and deploy all these nodes as Docker images in different cloud providers, and it would work. But for all intents and purposes, you're still interfacing with the Kubernetes API server to manage this fleet. I think we did a demo of this.
Yeah,
Of
you
this,
did.
like, yeah, this Kubernetes.
February, maybe?
Yeah.
It's a few months back at this point, but we did that early on to validate this design. Any other questions, folks?
No, thanks.
So yeah, please check out this blog. As we cut the release candidate, we'll post in Slack and be like, yo, it's time. Come try this out. We'll give you the steps to get started. And I think that's our main call to action for our community is to give it a shot and give us feedback. Right now, a lot of that activity is inside wasmCloud Wash, that repo that we were showing here. Um, we wanted to, it's such a major reimagining that we've kept it kind of separate from V1 so that we can keep V1 stable and doing its thing. And so this is effectively our home right now for V2. Um, any more we should say on that front, Lucas, before I start making callouts to events and stuff?
No, I think this is great. Yeah, and thanks for all the questions and all the feedback. This is great. Thank you.
Thank you, Lucas. Okay, so I have a special celebrity link for you today. If you didn't get your submission in for WasmCon and EU for next year, use my special link and by Friday, aka this week, maybe do it today while you're still thinking about it. Get a CFP in and maybe put in your talk about WasmCloud V2 and how great it is for you. Um, and if you need help on creating submissions or content or anything like that, please reach out to me or Liam. We love to help our community share their story. So that's the next one there. Wasm.io is also CFP is open, but that's till December. But don't wait, get it done. And yeah, we'll be posting more about what we're doing at WasmCon next week. Expect the community call next week to be pretty light because we're going to be on the floor. But we always like to say hi from the floor, so I'll sign in and show everybody around a little bit of the KubeCon floor. But I'm not planning on adding any agenda items or anything. And if you are going, we have this blog post here, WasmCloud at KubeCon NA 2025, and we're right here in the Project Pavilion. If you want to see some of the Cosmonic folks, we're actually like right here. So we can wave at each other between the two booths. This way. It's right here. This one. I don't know.
It's the first lower left green one, so a little over to the right. Yeah, right there.
I got it. Thanks, team. Okay. If you go to the Cosmonic site, we have a similar version of this blog, and it's actually called out. So if you are looking for us, you can find us. But also, if you just go to the WasmCloud booth and look around, you'll see us there too. And we also have, a ton of really exciting talks that I cannot wait to see and also be over with since some of those are my talks. So yeah, Liam, I saw you come off camera. I feel like you got something you want to say. You got something you want to say?
I just wanted to make sure we're going to go through this. That's all. It's just you, as usual, Bailey, are on top of everything. So it's great. I just want to make sure we just called out. I mean, travel could be a little weird for folks next week, but Bailey and I are driving, so we will be there with bells on like usual. I will actually be over. Our booth will be over at AI Day. If you want to see the sandbox MCP stuff, we'll have a little kiosk over there with wasmCloud and IDP Builder and a bunch of other stuff. And then, so that's Monday. We'll be at those two spots. Bailey will be running WasmCon. I'll be over at AI Day. We kind of divided up representation for folks. What's up, Frank?
Are the talks going to be streamed live or they're just going to be recorded?
No, they should be streamed live. If you log into your Linux Foundation account, you can follow the live stream there. I will drop a link in Slack. I'll pull that up right after the call. It should already be posted and published to get out. So you can watch those. I think Elizabeth's talk about WAM is going to be incredible. Bailey's got her talk with Flynn. Flynn was on moments ago. That's going to be pretty awesome. And Eric has a poster session during the happy hour on Tuesday, so he's going to be quite busy. And then we've got a bunch of fun demos that will be out on the floor as well. And I think I'm also forgetting a talk.
Mindy and Colin from
Oh.
Adobe are going to be, well, Mindy from Cosmonic and Colin from Adobe are going to be showing the content authenticity trustmark Onyx model running in wasmCloud with WASI Web GPU.
Which is brand new. I don't think anybody's ever seen it before, considering it just compiled for the first time last night at midnight. So that's exciting. So that's pretty awesome. And then on Tuesday, we'll be divided between the floor, and the wasmCloud kiosk is open in the mornings. If you look on the schedule, so for the first half of the day, and then the Cosmonic crew will be over there, and we'll happily host all the wasmCloud things over there as well. And then that's a Tuesday, Wednesday, and Thursday, and then yeah, so it should be a good time.
Yeah, absolutely. We do have 5 minutes left. And I did promise a WASI P3 update. Victor, are you game to give a 5-minute update? Or less?
Sure, I can give a super quick update. So right now, basically, I've been doing a bunch of work in the on the JCO side, so the open source Bytecode Alliance sort of stewarded project for the JavaScript ecosystem. And what I've been focusing on doing is adding async support. So at this point, Preview 3, which is the sort of next iteration of the component model that brings in features to both the component model and, of course, like this shows up in your WITs, in your sort of WebAssembly interface type interfaces and stuff. It brings in stuff like futures, streams, and being able to call components and have components call each other asynchronously. So right now, the implementation is mostly done and sort of looking really solid on the Rust side. And so what I've been doing is making sure that JCode transpile, which is a way to take a Rust component and convert it to run on a JavaScript runtime, any JavaScript runtime that supports sort of WebAssembly, like core WebAssembly, works with this new sort of paradigm and with the async component model changes. So that work has been sort of going, and again, it's a lot of sort of making sure things work the same, right? We want this sort of second host implementation to function similarly to the Rust implementation that already exists, and be able to use the Rust components that get written, right? So Rust has basically the best support, and it probably will for a while with regards to P3. And so people are sort of creating P3 components that do async things and making sure that we can run those with JavaScript as a host is what I'm working on. And so a bunch of sort of new tests and a bunch of bugs, thanks to Christoph from the WebAssembly community, who's been sort of banging on it and kicking the tires. Who found the bug, and we were able to get some fixes in. And so this kind of shows up in releases. So we're sort of, P3 support is still experimental, but we basically try and push out the pieces that are done as soon as they are done, so that they can, in some parts even not done, right? Since it's still experimental, but and let people try it, right? And so people have already been bringing their components that are in Rust and trying to run them. And so whenever we run into a bug there, we fix it and then keep going. So right now we're in the testing phase, the testing and fixing phase, essentially of the JavaScript implementation.
And thank you, Victor. I think what is so important is that this is our second reference implementation that allows us to move the standard forward. So once we have the second reference implementation, we'll be holding the vote in the WASI subgroup in the W3C, and the test that Victor's working on, like, we need a completed working test suite, but once we have it, we've done P3, and that is super exciting. So we're getting close. We're still on target for this year, end of year. I'm hopeful that we'll have it. And yeah, if like Victor called out, if you want to try out P3 today, you can definitely do it in WASM time. You're probably wondering right now, we just showed you WasmCloud V2. Does WasmCloud V2 have P3 in it? Right now, no. I'm expecting us to release WasmCloud V2 now, like as soon as we can stabilize, release, get feedback. Also before the end of the year, we'll release a V2, and not just the release candidate that we're cutting today. And then we would have a fast follow of upgrading to the latest version of WASM time that's stable on top of P3, where those interfaces are still kind of churning a little. Once that's stabilized, we'll bring in the latest version of WASM time, and you'll have it. And V2.0, maybe probably that's a minor rep. So it might be V2.1, might be V2.2, but it'll be this year too. And I think that's pretty exciting. So thank you for the update, Victor.
Yeah, no problem. And in the meantime, so changes to JCO itself still sort of progress. So if you've been watching, there have been a bunch of fixes that have landed. So thanks to members of the community that have been sort of filing issues as they ran into stuff or sort of asking about features. We found a lot of pieces of the JCO documentation that probably need some work. So that is probably, that's another place we're always happy to get help as well.
Yeah, so call to action, folks. Help us harden JCO for P3. Cool. Well, that's it for agenda. Unless any folks have questions for Victor, I think we're at time. All right. Well, thank you, everybody. I hope you have a wonderful rest of your week, and I'll see you from the KubeCon floor next week.